graphing. Up to this point, we've solved systems of equations by graphing. Today, we're going to learn an algebraic technique. Okay, so there's algebraic techniques, there's graphical techniques, there's correlation between the two things. But today, we're going to be using an algebraic technique to solve systems of equations, and that technique is called substitution. Yes? This is lesson 59. Tomorrow, we will do lesson 60. Okay? And that means we're finished with unit 6. Okay? All right, so we're solving by substitution. Now, we need to be reminded of some important things from just a few units ago. So, who can raise their hand and tell me what to put in these two blanks?
Something where the two lines meet.
Intersect.
Hey, Bo, raise your hand and tell me the answer to these two questions. Yeah, the solution to a system of equations is the point where the two lines intersect is the technical term for it. Where the two lines meet is true. So keep in mind that no matter how we solve it, what we're doing is finding the point of intersection of the graphs of the two lines. No matter how we solve it. So I'm solving by substitution. I'm still going to get a point as my answer, and that point is still going to be the point where the two lines intersect, assuming that the lines intersect, right? Do all lines intersect? No. Two lines in a plane cannot intersect. Plane is a flat space, coordinate plane specifically, if they are parallel. We just looked at an example from homework where we talked about parallel lines that do not intersect. But the solution to a system of linear equations is the point of intersection where the two lines intersect. All right, so let's solve this system of equations by substitution. Now, we need to kind of talk just a second about what substitution means. All right, what do we mean by substitution? When are we allowed to substitute? We're allowed to substitute things that are what? We're allowed to substitute expressions that are equal to each other, right? And we're used to doing this, right? We've been told before to, evaluate an expression or evaluate 2x plus 3 if x equals 7. And what do? We substitute 7 in the place of x and then assign a value to it. Why are we allowed to substitute 7 in the place of x? Because x is equal to 7. So what we're looking for in an expression to solve by substitution is things that are equal. Do you see anything in these two equations that are equal to each other?
X.
They both have y in them, don't they? What is y equal to? Y is equal to 2x minus 5, and y is also equal to 5x plus 7. So what does that tell us? Y is equal to both of those things, right? All right. So let me write this a different way. 2x minus 5 equals y equals 5x plus 7. Right?
So the expressions are equal to each other.
So 2x minus 5 has to equal to 5x plus 7. That's called the transitive property of equality. If a equals b and b equals c, then a equals c. Right? So if we have two things equal to a third thing, then the two things have to be equal. But what we're doing is we're actually using the substitution property. Because y is equal to 2x minus 5, I can substitute that right in there in the other equation in the place of y. We're making a substitution, and the result is going to give us an equation that only has the variable x in it. 2x minus 5 equals 5x plus 7 by substitution, and then we have an equation that we can easily solve, right? Write this down. Everybody write this down. This is not something you will remember how to do if you don't write it down. You need to be able to look back at this. Put a little box around that 2x minus 5 and draw that little arrow showing that we are actually making a substitution from one equation into the other. We're allowed to do that because y is equal to 2x minus 5. Now, when we solve this, we would subtract 2x from both sides or subtract 5x from both sides. Let's subtract 2x. And that will give us negative 5 equals 3x plus 7. I don't know where that x came from, but we'll take it out of the way. Subtract 7 from both sides. That will give us negative 12 equals 3x. And x is equal to what?
Negative 4.
Negative 4. Is that my solution?
No.
Why not?
It's not an ordered pair.
Because it's not an ordered pair. What are we solving? We're solving a system of equations. And the solution to a system of equations is the point or points where the two lines intersect. So x is equal to negative 4. Right? How do I find a value for y if I know what x is equal to?
Plug it into one of the equations.
All right, let's use a more mathematical term than plug it in. We substitute again, right? X is negative 4, so I can take this value for x and I can plug it in right there into either of those original equations. I'm actually going to plug it into both just to be safe. 5 times negative 4 plus 7. That's negative 20 plus 7, which is negative 13. So x is negative 4, y is negative 13. If that works in the other equation, then I am good to go. 2 times negative 4 minus 5. Does that also give us negative 13? It does. So this is indeed the point of intersection of those two lines. And we've solved it algebraically. Now, what should we expect graphically? If we graph this system of equations, what should we expect? We should expect them to intersect at that point. Now, you could do a real quick graph of these two things and just kind of see if it looks like they're going to intersect in that area, that vicinity. You'd have to change your window to actually see for negative 4, negative 13. But you could see real quickly where they're, if that's going to be the right ballpark for it. All right? So that's solving by substitution. Now, substitution there are some steps that we can look at for substitution. Solving systems by substitution, let's cover this before I go back and look at that next example. You first want to make sure that one of the equations is solved for one of the variables. All right? That means get either x or y by itself. In the previous example that we just looked at, it was already that way for us. All right? Both equations were solved for y. So I was ready to substitute into the other equation. But if I don't have one of the equations solved for x or y, then I have to do that. We can't substitute until we have what one of those variables is equal to, because we're only allowed to substitute equal values. Then we're going to substitute that value into the other equation. And that's going to give us an equation, one variable that we can solve. And then once you get the value of that variable that you solved for, you substitute that into one of the original equations to find the value of the other variable. All right? And then once you do that, you can check your solutions in both original equations. And we did that in that first example by just multiplying the two things, or putting the x value we found into both. If they generate the same y value, then you're good. Okay? So that's the process. You solve one of the equations to get a variable by itself. You substitute that into the other equation. You solve that equation to get a numerical value for one of the variables. Then you substitute that numerical value into one of the original equations to find the other variable, and then we'll have your point of intersection. Okay? Good? We'll come back and look at that again in just a second. Let's look at this previous example. So step number 1 says to solve one of the equations for one of the variables, to get one of the variables by itself. Do we have to do that step in this process, in this equation? No, because it's already solve for x, right? This second equation, we're told that x equals this. So what are we allowed to do with that expression? Substitute it into the other equation in the place of x. All right, so I'm going to have 12 times negative 2y plus 11 minus 6y equals 12. All right. This is my x value right there. Now that's not a difficult equation to solve. We need to distribute, simplify, and solve. We actually have all our variables on one side. So this will be negative 24y plus 132 minus 6y equals 12. Combine these two like terms, right? Subtract 132 from both sides. It's going to give me negative 30y equals negative 120. And when we divide both sides by negative 30, we get y equals 4. Is that the answer? No, because the solution to a system of equations is the point of intersection. So I need an x value and I need a y value. I'm going to take this y value and I'm going to substitute. This is the substitution method. So we do some substituting, right? Into that equation right there, I'm going to get x equals negative 2 times y plus 11. Negative 8 plus 11 is 3. So at this point, it appears that our solution is 3, 4. Check it. What's 12 times 3 minus 6 times 4? It's 12, right? And is 3 equal to negative 2 times 4 plus 11? We know that because that's the equation we just solved for. All right? So the solution is indeed 3, 4. Okay? So we want to get one of the variables by itself. We want to substitute that into the other equation in the place of that variable. We want to solve the resulting equation, substitute that result into one of the original equations to find the other variable, and check the solution in both equations. All right? Now this one we're going to have to do every step. Solve the system by substitution. What are we going to have to do first? Solve one of these equations. Now, which equation looks easiest to solve and for which variable? Because that's what we always want to do. Solve the top equation for y. And we can do that just by subtracting 2x from both sides, right? So y equals negative 2x minus 4. Now I have y isolated, which means this value can be substituted into the other equation in the place of y. Excuse me. 5x minus 2 times y is equal to negative 2x minus 4 equals negative 1. So we're going to get, I'm going to do this quickly, I'm going to skip some steps. 9x plus 8 equals negative 1. And solving that for x is going to give us x equals negative 1. All right, that is not my solution. I'm going to substitute that into one of my original equations. It really doesn't matter which one you use. Let's plug that in right there. 5 times x minus 2y equals negative 1. That's negative 5. So if I add 5 to both sides, that's going to give me negative 2y equals 4, which means y equals negative 2. All right. Substitute that into the other equation that we didn't use to solve for y. Make sure it's true. It's 2 times negative 1. 2 times negative 1 minus 2 equal to negative 4. Yes, it's negative 2 minus 2, and that is equal to negative 4. So we're going to go with that solution. Okay? Solving by substitution is, there's some. Your homework is 387 A through D, 1 through 17, 20, 21, 23, and 30. For accuracy, mañana.